Hi friends, welcome to Simplify Maths. Today we are going to learn rational numbers, chapter 9 for class 7. It is an introduction video. What are rational numbers? A number that can be expressed in the form P by Q, where P and Q are integers and Q not equal to 0. What do you mean by integers? Integers are, it includes 0, positive numbers on the right side, and negative numbers on the left side. It keeps on going endlessly. So a number that can be expressed in the form P by Q. See here, for example, 5 by 3 is a rational number, right? Similarly, minus 8 by 7, it is also a rational number. I am taking number from negative side and from positive side also I am taking as a denominator. Similarly, if you are taking full number 5, this is also a rational number. How it is a rational number? If you put 5 by 1, this is also a rational number. 5 by 1. Denominator should not be equal to 0. Other than 0, it may be any number. So every number is a rational number. Just keep it in mind. Even minus 7 by minus 3, whatever, these are all rational numbers. So have a clear concept about rational number. Rational number can be expressed in the form P by Q. That means fractional form, where P and Q are integers. See, in fraction also the expression is like P by Q. But there P and Q are whole numbers, not integers. That is the difference between a fractional number and a rational number. Important properties of rational numbers. In rational numbers, every natural number are rational. What are natural numbers? Just the set of 1, 2, 3, 4, only positive numbers. These are all the natural numbers are rational numbers. See, for example, if I am taking 3, how to express this in rational number? 3 by 1, we can express, no? Like this. Similarly, 4 by 5. So all are from the natural number. So from natural number set you can make rational number. So every natural number is a rational number. Similarly, every whole number is a rational number. What are whole numbers? Just include 0 in natural number set. That's all. 0, 1, 2, 3 and so on. It will go like this. So all the numbers are rational numbers. See, there is a concept. Q should not be, denominator should not be is equal to 0. See here, even 0 is a rational number. How? 0 by 1 is a rational number. 0 by any number is a rational number, right? So 0 is also a rational number. 3 by 5, anything we can do. Every integer is a rational number. Integers, just we have seen, no, these are all integers. That means all the positive numbers and negative numbers also, if we include, that is called integers. So whatever number you can take, it is a rational number here also. All the number divided by 1 is a rational number. We can give it in the fractional form also. See, 2 by minus 7 is a rational number. Here we are including negatives also. Even minus 11 divided by minus 5 is a rational number. Every integer is a rational number. Even every fraction is a rational number. How? All the fraction, because fraction also bound to the property of rational numbers. Fraction is in the form A by B, where B not equal to 0. A and B belongs to whole number. Every fraction, 4 by 3, 17 by 16, whatever you take, these are all rational numbers. The only main thing we need to give our concentration is rational numbers not allow 0 in denominator. That's all. Important note, division by 0 is not allowed. So a rational number cannot have 0 in the denominator. Numbers can be divided into two. Positive rational number, negative rational number. If both the numerator and the denominator are positive, then it is called a positive rational number. See here, suppose 3 by 1, numerator, denominator positive. Even 7 by 6, positive rational number. Also, if you see minus 14 divided by minus 3, this is also positive, because negative by negative, like sign means it is positive only, right? So both the numerator and denominator are positive. Otherwise, it should have the same like signs in the numerator and denominator. That's all. Negative rational number. Either numerator or denominator is negative. I'll give you example. Minus 5 by 3. In this, numerator is negative. Similarly, 8 by minus 5. Here denominator is negative. So it is negative rational number. We can give enormous example like this, minus 1 by 4, etc. Whatever. These are all negative rational number. Equivalent rational number. If a by b is a rational number, then a into m divided by b into m is equal to a by b, where m not equal to 0. I'll show you. 3 by 2 is a rational number, right? We are going to find the equivalent to this rational number. How to do? 3 by 2. If we are multiplying the numerator and denominator with the same number, let our m here is 3 or 4. Let us take it as 4. So multiply 4 in the numerator and also in the denominator. 4 3s are 12 divided by 4 2s are 8. Right? So this is equivalent. 3 by 2 is equivalent to 12 by 8. Similarly, suppose if you are taking m equal to 2, what will come? 2 by 2, right? Numerator 2, denominator is also 2. So 3 2s are 6, 2 2s are 4. So this is also equivalent. These are all equivalent. See, this 3 by 2 is equal to 6 by 4 and this is equal to 12 by 8. We can find enormous equivalent rational numbers. This is one way. Another thing, if a by b is a rational number, then if you divide the numerator and denominator by the same number, that is also will give you equivalent rational number. Let us do that also. For example, if 32 divided by 24, it is a rational number, right? Take m equal to 2. Okay. So we are going to divide numerator and denominator by this 2. Okay. So 32 divided by 2 gives us 16 divided by 24 divided by 2 is 12. This is a equivalent fraction. Now take m equal to 4. What will happen? 32 by 24. We are going to divide the numerator and denominator by 4 here. So 32 divided by 4 gives us 8. Here it will give us 6. So these are all equivalent fraction. See here. These are all equivalent rational numbers. Simplest form. How to find the standard form of a rational number? For example, 32 by 24 is a rational number. When the numerator and denominator have no common factor other than 1, that is called the simplest form or standard form of rational numbers. See here, in 32 and 24, there are common factors, right? So how to do this? Find HCF, simple HCF, 32, 24. What is the HCF? If you are doing it with 2, 1, 6. This is 12. Again 2, 8. You are dividing, that's all, dividing these number by 2, 6. Again with 2 you can divide. This is 4 and 3, that's all. So HCF is equal to 2 into 2 into 2, which is equal to 8. We should not take these numbers into consideration because both doesn't have any common factor. So this is our HCF. We need to just divide the numerator and the denominator by the HCF. So 32 divided by 8 gives us 4. 24 divided by 8 gives us 3. That's all, 4 divided by 3. This is the simplest form or standard form of the given rational number. Because there is no common factors between 4 and 3, we cannot cancel 4 and 3 after this. So this is the simplest form. How to do directly? No need to find HCF anything. Just cross it. We know 2 is the common factor. Very nicely we know 2 is the common factor. Just divide like this. 1 time 2 is here. So 6. Here 1 time 2, 2 time 2. Again we can cancel this. This is with the 2. 8 times. Here 6 times. Again we can cancel by 2. So this is 4 and this is 3. So ultimately we get our answer as 4 by 3. So using this cancellation method also you can do this, or find the HCF and divide using that HCF in both numerator and denominator and find the standard form or simplest form of the rational number. A by B and C by D are equivalent, that is equal or not. What we need to do? We need to use property of cross product. See, A by B and C by D are equal if cross product means AD. Just multiply crossly. AD is equal to BC. These two rational numbers are not equal if AD, cross multiplication, AD is not equal to BC. This is the thing, that's all. For example, 3 by 2, comma, 6 by 4. We are going to find these are equal or not. If it is equal, if you multiply crossly, it will be equal. 3 into 4 is equal to, just check, 2 into 6. 3 4s are 12. 2 6 are 12. So these are equivalent fraction. That means 3 by 2 is equal to 6 by 4. Both are equal. If we cancel this rational number using 2, 3 times and this is 2 times, we ultimately get our simplest form, 3 by 2. So both are equal. Just to do cross multiplication, that's all. We are going to check whether these two are equal. Just to multiply, cross multiply. 3 into 7 is equal to 2 into 5. This is 21. 3 7s are 21. 2 5s are 10. Not equal. Not equal. So these rational numbers are not equal, not equivalent. Comparison of rational numbers. Comparison means we are going to find which rational number is greater or lesser. We will see. By two types we can compare rational numbers. First, finding their cross product. Two rational numbers, A by B and C by D. Okay. The cross product is, what is the cross product? AD and BC, right? If AD is greater than BC, then A by B is greater than C by D. If AD is less than BC means then A by B is less than C by D. Shall we compare these two? 2 by 3 and 5 by 2. We are using cross product to compare. So find cross product. Cross product is 2 2s are 4. 2 into 2 is equal to 4. Comma. 3 into 5 is equal to 15. So we have found our cross product. Now, this is AD and this is BC. Here 4 is less than 15, right? That is AD is less than BC. If AD is less than BC, then first rational number is less than second rational number. So this is our first rational number. This gives this 2 by 3 is less than 5 by 2. That's all. This is how we compared here using cross product. Now we will compare the rational numbers using LCM of the denominators. First, find the LCM of this denominators alone, B and D. Then change the given rational number according to LCM. Now compare the like fractions. That's all. Easy. We will do. See here, 2 by 3. Same thing I am going to take. 2 by 3 and 5 by 2. So we are going to find LCM for 2 and 3. What is the LCM of 2 and 3? So LCM is equal to, if there is no common factor, always given a product of the given number is the LCM. Okay. LCM is 6. First rational number. Make the denominator as 6. We need to multiply it with the 2. So numerator is also with the 2. This is equal to 4 by 6. Correct. Now 5 by 2. To make the denominator 6, we need to multiply it with 3. So numerator also with 3. We cannot do only for denominator. Whatever you are doing for denominator, you should do it for numerator also. This is equal to 15 divided by 6. Now 4 by 6 and 15 by 6. In like fraction, numerator with the smaller number is the smaller. Numerator with the bigger number is the bigger. So 4 is less than 15 here. So 4 by 6 is less than 15 by 6. The simplest form of these things are 2 by 3. So 2 by 3 is less than, this one is 5 by 2. So ultimately we got the same answers by using both the methods, using cross product and using LCM of the denominators. How to find rational numbers between two rational numbers? It's very easy. Just to find the LCM of the given denominators, convert the given rational numbers to equivalent rational number with the same denominator. Find more rational numbers in between them. That's all. See here. Here we have two rational numbers, right? So what is the LCM? LCM of the denominator 5 and 3 is, there is no common factor. So LCM is 5 into 3 is equal to 15. Correct? This is our LCM. Now we are going to convert this minus 4 by 5. To convert it into equivalent fraction with the denominator 15 means we need 3 only, right? 3. Here also 3. Multiplying 3 with the numerator and denominator gives us minus 12 by 15. Now minus 2 divided by 3. To make the denominator 15, just to multiply it with a 5. So here also with a 5. This is equal to minus 10 divided by 15. So now we have minus 12, minus 10, two rational numbers. In between, how many rational number will come? Minus 11 by 15. So we can find only one rational number, but the equation is find three rational numbers. So for that, what we need to do? No problem. Just find the equivalent fraction for both using the same denominator. With the same denominator, then it will be easy. For this, what we need to do is take this minus 12 by 15. Multiply it with 2. Whatever number you want, you can multiply. Just to make both the denominators equal. So this becomes minus 24 by 30, right? I changed this. Now I am going to change this to make the same denominator, multiply with the same number 2, here also 2. This is minus 20 by 30. Now listen here. This is minus 24 by 30. Just think of a number line. This is minus 20 by 30. How many numbers will come? Minus 21 by 30, minus 22 by 30, minus 23 by 30, here minus 24 by 30. So already we have found one rational number in between these two. Here we have found 4 more rational numbers in between these two. See, this is nothing but minus 24 by 30. If we divide 6 with the numerator and denominator, what we will have? 24 by 6 is minus 4. 30 divided by 6 is 5. See, this is our first rational number. So this is nothing but this one. Now this, if you take this, what is the common factor between these two? Common factor, so many common factors. HCF is 10. If you divide this by 10, we will have minus 2 by 3. Ultimately our second rational number. So this is nothing but. So between these two rational numbers, we have found 4 more rational numbers. Here already 1. So 5 rational numbers. The question is find only 3 rational numbers between these two. But we have found out 5 rational numbers. So enormous rational numbers. Infinite number of rational numbers we can find between any two rational numbers. Addition and subtraction of rational numbers. Here also the same thing, just find the LCM of the denominator and then convert it into the equivalent fractions with the like denominators as a like fraction actually. So now LCM of denominators 11 and 9. There is no common factor between these two. So LCM is 11 into 9, which is equal to 99. Now we are going to make this minus 3 by 11 into equivalent fraction, which gives us 99 in the denominator. For that, what we need to do? Multiply it with 9 in numerator and denominator. So this is minus 27 by 99. Okay. Now this 5 by 9. How to convert it? Just multiply it with 11. 5 into 11 by 9 into 11 gives us 55 by 99. Now we are going to add these two. So minus 27 by 99. Equivalent fraction only. So instead of this minus 3 by 11, this is also equal. So this is added with 55 by 99. If the denominators are equal, we can add the numerator minus 27 plus 55. This is equal to 55 minus 27 is 28 divided by 99. So easy. In the similar way, we have to do subtraction also. Here also we need to find the LCM for the denominator. Here LCM of 36 and 24 fully we have taken. So this is equal to 2 2s are 4, 4 3s are 12, 12 3s are 36, 36 2s are 72, 17 by 36. To make denominator 72, we need to multiply it with 2, right? So 17 into 2 is 34 by 36 into 2 is 72. So we have converted this. Now 7 by 24. How to make this as 72 denominator? What is the number we need to multiply? Here we need to multiply it with 3. Here also 3. This is 21 divided by 72. This is equal to 17 by 36 only. Don't get confusion. This is equal to 7 by 24. Both are equivalent, means equal. So we are going to subtract this from this. Okay, from. This is from. This should come first. So instead of this, we can use this. 21 by 72 minus 17 by 36. Instead of this, we can use this. 34 by 72. This is equal to, if the denominator is common, we can do addition or subtraction. So here subtraction. 34. So 34. 21 minus 34. So negative 13 divided by 72. Answer is minus 13 by 72. Multiplication of rational numbers. See, if we have rational numbers a by b and c by d, how to multiply? Just multiply the numerator divided by multiply the denominator. That's all. Here also 5 into 8, just multiply 5 into 8, 3 into 7 in the denominator. Whatever numbers we need to multiply wherever it is. That's all. 8 5s are 40 divided by 21. Now division of rational numbers. If a by b divided by c by d is equal to, a by b will come as it is into reciprocal of this c by d, d by c. After that, as usual, multiplication, a into d divided by b into c. Let's see by an example. This is equal to 2 by 3 into reciprocal, means ulta, 5 by 8. Reciprocal is 8 by 5. That's all. See, 2 into 8 divided by 3 into 5. This is equal to 16 divided by 15. That's all. How to convert rational numbers as decimal numbers. All rational numbers can be converted into decimal numbers. Also, these decimal numbers can be broadly divided into two parts. Terminating decimals, non-terminating decimals. Terminating means ending decimals. Non-terminating means it will keep on going. That is called non-terminating decimals. Terminate means end. Finite number of digits after the decimal point. It will end at some point. See here, 1 by 4. This is an example. How to convert it? 1 divided by 4. So, we will have 1 point, so we will have 0 here. 2 times 4 is 8. Here 2 will come, 0. 5 times 4 is 20, right? While converting a rational number into a decimal, if we get 0 as the remainder, keep it in mind, 0 as remainder, we get terminating decimals, 0.25. That's all. Over. After that, it won't continue. 0.25. This is the end of the decimal number here. So, these are all called terminating decimals. So, with this, it won't extend. Now come here, non-terminating decimals. Non-terminating decimal means it won't end. Non-terminating decimal also classified into 2 types. Non-terminating recurring decimals. That means after point repeating numbers come. Repeatedly same number will come. Non-terminating non-recurring decimal means the decimals will continue but the numbers are different each time. See here, 1 by 3. If you divide this 1 by 3, we will get 10. So what will come? Here 3 3s are 9. Again 1 will come. How many times? Again 3 times. 9. Again 1 will come. 10. Again 3. So it will keep on going endlessly. This is 0.33333. Numbers also repeating. So these are all called non-terminating. It won't get any end. It won't end. So non-terminating recurring. That means repeating decimals. This is called non-terminating recurring decimals. In some example, if we divide some number, answer will be like this, 0.67453927. So randomly it will keep on going like this. It is also not repeating. So these are all called non-terminating, also non-recurring decimals. That means non-repeating. Numbers are different each time. So non-terminating, non-recurring decimals. Hope you understand the rational number concept clearly. In our next video, we will do all the exercise problems. Thank you.